Take a look at this first question. It says, two goalposts are 8 meters apart. A footballer is 34 meters from one post and 38 meters from the other. Within what angle must he kick the ball if he is to score a goal? Now, for a question like this, what I need to do first is to draw the figure. It says two goalposts are 8 meters from each other. So that's the first one. There's the second one. 8 meters apart. A footballer is 34 meters from one, so as many footballers here, so it's 34 meters from one, and then 38 meters from the other, which is this one. So the question is, within what angle must he kick the ball if he is to score a goal? He's going to kick within this angle here. That is the theta. That's the angle within which he's going to kick the ball for him to be able to score a goal. For a question like this on bearing, you have three sides and you're looking for one angle. What you need to use here is called the cosine rule. So for the cosine rule, since this one is the side facing this angle, I'll have what the square of this side, which is a square, will be equal to 34 square plus 38 square minus 2 times 34 times 38 cos theta. We are looking for what theta. I talked about the using what cosine rule. I'm making use sine rule. I talked about the cosine rule in the part 1 of this series. If you have not watched that, you can watch that series, but later there are some things you learn from that particular part 1 of this series. So now the next thing is to get the value of what theta. Now to get the value of theta, you can take everything here to one side, okay? Take this one to the other side, so that we have 2 times 34 times 38 plus theta will be equal to 34 squared plus 38 squared minus 8 squared. So now, if we work on that, we have 2 times 34 times 38. So that will give 2584. Plus what theta. So here we have 34 squared plus 38 squared minus 8 squared. And that will give 2536. So now we have cos theta equals 2536 divided by 2584. We have to divide by the coefficient of cos theta. And what we divide is 1. We have cos theta equals 2536 divided by 2584. That gives 0.9814. So theta will now be the cos inverse of 0.98104, and that will be about what? 11 degrees. That will be about what? 11 degrees. So that is the angle within which he's going to kick that ball if he must score a goal. It's not something that is difficult. Bearing and distances is not a difficult topic. Follow me closely. There are some interesting examples I'm going to show you today in this series, different from what we did in our previous class. Let's look at example 2. Two boats, A and B, left a port C at the same time. On different routes. Stop. B traveled on a bearing of 150 and A traveled on the north side of B. Stop. Where A travels 8 kilometers and B traveled 10 kilometers. The distance between the two boats was found to be 12 kilometers. Calculate the bearing of A's route from C. Calculate the bearing of A's route from C. Now take a look at this question now. The two boats left a port towards C. So let's say this is the port towards C. That's port C. They travel at a bearing of 151 degrees. We're going to start from here, cross this part a little. Remember, if it gets to this point is what? 180 degrees. So since what I need is 150, and get to the point here, call that point what? 150 degrees. That's the point what B. They traveled on the north side of what B. On the north side of what B. So it's traveling towards this part. That's the north side here. It's traveling towards the north side of B. On the north side of when A has traveled 8 kilometers, B has traveled what 10 kilometers. So here is 10 kilometers. Here is what 8 kilometers. Now this one, that's point what A. So the distance between the two boats was found to be what? 12 what kilometers. So yes, 12 what kilometers. Calculate the bearing of A's route from C. The bearing of A's route from C is talking about what? The measurement from the north pole of C up to this particular point. From here to this particular point. Now, I know that from here to this point is what? 150. So for me to get this one, if I get this in angle, I subtract from 150, I'll get this particular what? Angle here. For the entire angle here is what? 151 degree. So this inner angle, let's call this inner angle what? Theta. For the entire angle is what? 150. So the bearing I'm looking for from here to this point, let's call it what? Alpha. So alpha plus what? Theta is what? 151 degrees. So to get the value of what? Theta, since I have three sides here, and we are looking for this particular angle, I also make use of what? The cosine what? Rule. Just in case you missed the first part one of this, cosine will say c squared is what? A squared plus b squared minus 2ac cos what? C. That's the angle facing what? The side we are looking for. So now, in this case, this c squared here is represented with this 12. A squared is for this one. Then b is this other side here, 10. So this angle c becomes what? Theta. So 12 squared using cosine rule. Using cosine rule, our 12 squared equal to 8 squared plus 10 squared minus 2 times 8 times 10 cos theta. So now, this one will give us 144. This one will give 64. This one is 100. This one is 160. Cos what? Theta. So now, collection of like terms, I'll transfer this one across this way. So I'll get 160 cos theta equal to 64 plus 100. That's 160. Transfer 44 across minus 144. So now I'll get 160 cos theta. That gives us what? 20. So that cos theta will now be 20 divided by what? 160. So that cos theta will now be 0.125. So that theta becomes the cos inverse of 0.125 now 82.8. 82.18. So alpha is what we are looking for. That's the bearing of A from what? C. So I'll get alpha plus theta equal to the entire angle, which is 150. So we have alpha plus 82.8 equal to 150. So that alpha will now be 150 minus 82.8. That will give us about 67.2. So that is the bearing of A from what? C. The important thing here is just to know how to draw what the diagram. Learn how to draw the diagram. Once you can draw the diagram, you can actually solve that question correctly. I'm going to write a third example on the board now. What you do after I write the question on the board, pause the video, try to draw the diagram on your own. And after drawing the diagram, you play the video and check to compare your diagram with the one I've drawn. Then possibly pause the video again, solve the question before looking at the correction on the board. That is the best way for you to learn what you are doing here under bearings and what distances. Let's take a look at example 3. This is something more technical now. The surveyor leaves a base camp The surveyor leaves a base camp and drives 42 kilometers. And drives 42 kilometers on a bearing of 0.32 degrees. The bearing of 0.32 degrees. Stop. He then drives 28 kilometers. (0.32). He then drives 28 kilometers on a bearing of 154. The bearing of 154 degrees. Stop. How far is she then? How far is she then from a base camp how far is she then from a base camp, and what is her bearing from it? And what is her bearing from it? Okay, let's see how to draw this diagram. The surveyor leaves a base camp and drives 42 kilometers on a bearing of 0.32. 0.32. Let's say it's the base camp. Let's call it B to represent the base camp. Drive 42 kilometers on a bearing of 0.32. Remember, I said we'll measure from the North Pole. From here to this point is what? 90. So 32. I can stop at any point here. Call that 0.32 degrees. You then drive, okay, that's 42 kilometers. This one is 42 kilometers. 42 kilometers. He then drives 28 kilometers on a bearing of 154. We cut across the 90-degree point, but it's not going to be 180 points. And here we're talking about what? 28 kilometers. Of course, 42 kilometers is going to be longer than 28 kilometers, so I can stop at that point. How far is he then from our base camp? This is the base camp. So I'm talking about the distance from here to this point. We draw here, we have this one. So now, there are two questions here. How far is she then from her base camp? Let's call that distance D. And what is her bearing from it? Her bearing from the base camp is the entire angle from here to this point. That's her bearing from the base camp. So that means I'm going to get this value of theta, add it to what? 32. That will give me what? A bearing from the base of camp. So the first thing is for me to get what? The distance will be. Now for me to get the, yes, 32. So now the 32 is somewhere like this. And then we have this one. This angle is also going to be what? 32 degrees. That's alternate angles. Alternate angles are equal. That's from angles and lines. There's a rule that says alternate angles are equal. Alternate angles are angles in the form of what? Letter or Z. So here is 32. This inner part is also what? 30 what? 2. So here is 32. And then remember, from here to this point was 154. So from here to here is what? 180. So if here is alpha now, alpha will be 180 minus what? 154. And that will give us what? 26 degrees. Okay, so here's 26 degrees. So the total angle here will now be 32 plus what? 20 what? 6. And if you add up that, you get what? 50 what? 8 what degrees. That's the value here. 58 what degrees. So now that I have that angle, I can get the value of what? D using the what? Cosine what? Rule. Okay, so using cosine rule now. Using cosine rule, we have this square equal to 42 square plus 28 square minus 2 times 42 times 28 cos the angle facing the side we are looking for. That's cos what? 50 what? 8. So I'll get this square equal to, we have 42 square now. That will be 1764. 28 square. That will be 784. Then we have 2 times 42 times 28. 2 times 42 times 28. I'll give 2352. 2352 cos 58. Okay, is there a value of cos 58? So I have 0.5299. .5299, so that we have this square equal to 1764 plus 784 that will be 2548. And we have 2352. 2352 times 0.5299. Log in 1246 1246.32. So now we have this square equal to 2548. 2548 minus 1246.32. That will give 1301. 1301.68. So now to get the value of t now, you take the square roots. That will give 36.1. .1 kilometers. So that's the distance from the base of camp. So the next thing is a bearing from the base camp. So like I said, to get a bearing from the base camp, you have to get what theta first. After getting theta, you add what 32 degrees. Now to get the value of theta now, I have this side, I don't have this angle, I have this angle, and I have this side. So now what I will make is to get the value of theta is the sine what rule. So using sine rule, based on the sine rule, not a part 1 of this series. So we have sine theta, the angle we are looking for, all over the side facing theta, which is 28. That will be equal to sine 58 all over d, which is 36.1. Okay, so we get sine theta equals 28 sine 58 all over 36.1. That's we cross what multiply. The cross multiply, the 28 goes to multiply sine of 58. So we get 28 sine 58 divided by 36.1. So I'll get sine theta equal to. So work on that now. We have 28. Let's just do that directly. Sine 58. So I'll give 23.75. So we have 36.1. So 23.75 divided by 36.1. Now it's 0.65718. 65718. Okay, sine theta 0.657 6579. Okay, 6579. So that theta will now be the sine inverse of 0.6579. Theta will be equal to approximately 41. Let's say 41.1 degrees. 41.1 degrees. So now the bearing we are looking for now, that's the angle from here to this part, is going to be 32 plus what? Theta. Okay? So the bearing, a bearing from the starting point. Bearing from starting point That will be theta plus 32, and that will be 41.1 plus what? 30.2, and that will be 73.1 degrees. That is a bearing from the starting point. So that's how we use the sine and the cosine rule to get the distance and what? The bearing. Okay? So if you have not watched the part 1 of this series, after this you can go back and watch the part 1. It will give you a little understanding or further understanding of what we are doing under what bearing and what distances. Let's look at the next word example. If you have any question on this, you can send it to me through the comment word section. I'll respond to you. Let's see the next question. Probably example 4 now. Example 4. Says 2 ships leave port at the same time. Leave port at the same time. 2 ships leave port at the same time. First of all, one travels at One travels at 5 kilometers per hour. On a bearing of 0.46. On a bearing of 0.46 degrees. The other travels at 9 kilometers per hour. The other travels at 9 kilometers per hour on a bearing of 127. The bearing of 127 degrees. This is called how far apart are the ships after 2 hours. How far apart are the ships after 2 hours? How far apart are the ships after 2 hours? Okay. Now, for a question like this, it's still the same principle. The first thing is to draw the diagram. So now pause the video. Try and see if you can draw the diagram on your own. If possible, solve the question first. Thereafter, you can play the video again and check what the solution. So now 2 ships leave port at the same time. One travels 5 kilometers per hour on a bearing of 0.46. 0.46. Let's say that's a port. Let's represent that with what P. One travels 5 kilometers on a bearing of 0.46. 0.46. Point P 0.46. I'll stop there. Take it up. 0.46. 5 kilometers per hour. 5 kilometers per hour. Okay, let's hold on first. The other travels at 9 kilometers per hour, the bearing of 127. We leave the same point. So start from here again. There's 90. I'll cut across that point a little to get my 127. So that's 127 from here to this point. Is 1 or 2 or 7. So remember, here's already what 46. That means here is going to be what 81. That will be 81. That is 46. 81. That will be 1 towards 7 degrees. Okay. Nine kilometers per hour bearing of 1 towards 7. How far apart are the ships after or 2 hours? After 2 hours, this one is traveling at 5 kilometers per hour. That means in 1 hour, it's going to travel 5 kilometers. So in 2 hours, that will be what? 10 kilometers. That's why I said just hold on. Then the other one was traveling at 9 kilometers per hour. So in 2 hours, that will be what? 18. That will be 18. So now this one will be shorter here. Okay. Now join this one here. Okay. How far apart are the ships after 2 hours? So I'm looking for this distance here. So now we have this side, we have this part, we have this angle. So what I'll use is what? The cosine rule. Use the cosine rule. I'll get this square, which is the part I'm looking for. That will be equal to 18 square plus 10 square minus 2 times 18 times 10 cos the angle facing the side we are looking for. So I'll get this square equal to 18 squared, that's 324. We have 100. Then we have 18. Well, we have 360 here. Plus 81. 0.1564. Zero point 15644. So now we have this square. 424 minus. We have 0.1564. 1564 times 360. That will give 56.304. So we have this square equal to 424 that will give 367 .696. Please 67.696. That will give 19.1. 19.1. So how far apart are the shifts after or 2 hours? So this square, deal with me, square root of 367.696, say approximately 19.2. 19.2 kilometers approximately. It is not something that is difficult. So if I ask to calculate the bearing from the starting point, that would now be, so the place present location now. You can say the bearing of this, okay, bearing of this sheet from starting point, that's really this, okay. Let's look at the next example. Let's look at the next example. That'll be example 5. The boat says 4 kilometers. The boat says 4 kilometers on a bearing of the boat says 4 kilometers on a bearing of 038. And then 5 kilometers on a bearing of 067. On a bearing of 067. The boat says 4 kilometers on a bearing of 038. And then 5 kilometers on a bearing of 067. Full stop. And how far is the boat from its starting point? A. How far is how far is the boat from its starting point? That's A. The B. Calculate the bearing of the boat from its starting point. Calculate the bearing of the boat from its starting point. From its starting point. So that's the second question. My boat says 4 kilometers on a bearing of 038. And then 5 kilometers on a bearing of 067. Okay, let's start from here. 038. Draw a line from here to a particular point here. Let's put here at 038. 5 what? Okay, 4 kilometers. Okay, 4 kilometers. And then 5 kilometers on a bearing of 067. 5 kilometers on a bearing of 0.67. How far is the boat from its starting point? That's the starting point. So that's what we're looking for, the distance. So calculate the bearing of the boat from its starting point. The bearing of the boat from the starting point is going to be from up here down to this point. So I'm going to calculate what theta. So the bearing of the boat from the starting point is going to be theta plus what 38. Theta plus what 38. So the first thing is for us to get the value of d. What I need to get first is this one inner one angle. Now yes, 38 degrees. What I said previously, alternate angles are equal. That's angles in form of what z. So here is 38. So that means this inner part is going to be what 38. So here is 38. Here is 90. Then here to this point here is also what 90 degrees. So let's get this small part here. Let's call that one alpha. To get alpha, we subtract 67 from what 90. 67 from what 90. And that will be what 23 degrees. So the total angle here, let's call that angle y. Y will now be 38 plus 90 plus 3. So that the angle y .38 plus 90 plus 23. So that will give 151 degree. So now that I have that angle, I can now calculate the distance using what cosine rule. So using cosine rule, I'll get d squared equal to 4 squared plus 5 squared minus 2 times 4 times 5 plus the angle 151. So this square equal to 16 plus 25 minus 40, then cos 151. That will be minus 0.8746. 8746 minus 0.8746. So I get this square. Add up this and this. That will give 41. Minus is what? Plus. So get 40 times 0.8746. So I'll give 34 points. 984. So this square, that would be 75 points. 75.984. To find the square roots, would now give 8.712. 8.712. 8.72, that's square root of 75.984, 8.72 kilometers. So the next thing we have to calculate is the bearing. The bearing from the starting point, that will be the angle theta plus 138. So I'll make use of what the sine watt rule. So most times on that bearing, whenever we're looking for the angle, we make use of the sine rule. If we're looking for the sine, we actually make use of what the cosine watt rule. Now, I'll get the value of what sine theta, but I'll get using sine rule. I'll get sine theta all over t. Okay, no. Sine theta over the side facing theta now. That's 5 kilometers. That will be sine of this angle. This angle is 151. All over d, which is 8.702. So we get sine theta equal to the cross multiply. The cross multiply, you have 5 sine 151 all over 8.72. So I'll get sine theta equal to 5 sine 151 that will be 2.4240, 2.4240 all over 8.72, 4240 divided by 8.72. That gives us 0.278. 2780. 2780. So theta will be equal to sine inverse of 0.2780 that is 16.14. Therefore, the bearing will be theta, that's 16.14 now, plus 130 what is. So that is 16.14. So that's the bearing. So most times on that bearing and distances, when we are looking for the bearing itself, most times we make use of what is the sine or rule. And when we are looking for the side, we often make use of what the cosine or rule. So the most important thing is to learn to draw what the diagram. If you can draw the diagram, then possibly you will be able to solve what the question. Let's take a look at one more example. Let's see. Now the example 6. This is actually a why question this time around. This is a why question. So an aeroplane flies due north. An aeroplane flies due north from Ikeja Airport from Ikeja Airport. An aeroplane flies due north from Ikeja Airport for 500 kilometers. For 500 kilometers. It then flies on a bearing. Then flies on a bearing. It then flies on a bearing of 060 of 060 degrees for a further distance of 300 kilometers. Before overflying a road junction, first of all, calculates, and the A part of the question says the distance of the aeroplane from Ikeja Airport. The distance of airplane from Ikeja Airport distance of the airplane from Ikeja Airport. When it was directly above when it was directly above the root junction. Then B, the bearing. The bearing of the airplane from Ikeja Airport at this instant. Okay, first thing is to draw the diagram. Let's see how to draw the diagram. The airplane flies due north from Ikeja Airport for 500 kilometers. Due north. The airplane flies due north from Ikeja Airport. So let's say this is Ikeja Airport. Let's represent that with A. Flies due north. An airplane flies due north from Ikeja Airport for 500 kilometers. So let's say 500 kilometers. It then flies on a bearing of 060 degree. 060 degree. 060 degree for a further distance of 300 kilometers before overflying a road junction. Calculate the distance of the airplane from Ikeja Airport when it was directly above the road. Okay, so those other ones are just stories. So we have this. That's the distance we are looking for. So what I will get is this in angle here. This part here is 90. This part remaining here was 60 because from here to here is what? 90. So if I remove 60, or better still, from this point here to this point is what? 180 degrees. So if I remove what? 60 from the 180 degrees, I'll get what? 120 degrees. So this in angle is what? 120. But you just say the 90 plus what? 30. That is still 120 degrees. So now I have that. The next thing is the bearing of the airplane from Ikeja Airport. The bearing of the airplane from Ikeja Airport is talking about this angle here. That's it. So if you look directly what north, flies due north from Ikeja Airport, that's due north directly. It then flies on the bearing for a further distance of 300 kilometers before overflying the road junction. Calculate the distance of the airplane from Ikeja Airport when it was directly above. Then the bearing from Ikeja Airport. So that's just theta. So this one is even easier than most of the questions that we have done. Only the questions same what length. Okay, so it's not actually the length of the question that matters. Just try as much as possible to draw the diagram. If you can draw the diagram, then possibly you can solve the question. So from here, I'll make use of the cosine rule now. Using cosine rule. Use the cosine of this square will be 500 square plus 300 square minus 2 times 500 times 300 cos 120 So we have this square. We have 2500 1, 2. This one is 300,000. We have cos 120, that's minus 0.5. So we have this quick. So I have 340,000. Minus is plus. 300,000. That 150. Now 490. So B will be square root of 490,000. That will be 700 kilometers. So that's the bearing. Oh, sorry, that's the distance, right? The distance from the Ikeja airport. So the next thing is to calculate the bearing, which is this angle now. So to get this one now, make use of what? The sine what rule. So I'll get sine theta. Make it of the sine rule, so I'll get sine theta. All of its sides facing theta, that's 300, equal to sine 120 all over d, which is 700. So I'll get sine theta equals 300 sine 120 all over 700. So I have 300 sine 120 plus sine theta equal to 259 points. 259.81 divided by 700. 259.81 divided by 700. So we get sine theta equal to 0.371371 So the angle will be approximately 21 point, let's say 21.8. 21.8. Theta becomes sine inverse of 0.3712, approximately 21.81 degrees. That is the bearing. That is the bearing. It is not a difficult question. So even if the question seems lengthy, it doesn't mean that's going to be what difficult. Just draw the diagram. You can draw the diagram. Then you may be able to solve that question with that. Let's see yet another technical question than this. an aircraft flies round a triangular, an aircraft flies round a triangular course. An aircraft flies round a triangular course. The first leg is 200 kilometers on a bearing of 115. And the second leg is 150 kilometers on a bearing of 230 degrees. The bearing of 230 degrees. How long is the third leg of the course? And on what bearing? And on what bearing? And on what bearing must the aircraft fly? On what bearing must the aircraft fly? Question says it's moving in a triangular course. So it flies around the triangular course. The first leg, 200 kilometers on a bearing of 115. Let's say start from here. (200 kilometers) bearing 115. Bearing 115, so I start from here up to a point here. That is 115. The distance is 200 kilometers. Second leg, 150 kilometers bearing 230. Bearing 230. This 180. 230 should be around here. (150 kilometers) 230 degrees. First one, 200 kilometers, 115. Second one, 150 kilometers, 230. 230, 150. So how long is the third leg of the course? So we're looking for this one. That's the distance. And on what bearing must the aircraft fly? So this third course, so the aircraft is going to fly from here, that's the North Pole now, from here down to this point. That's the bearing we are going to look for. That means the first thing I need to get is to get this angle here. Let's call that alpha. Once you get that angle, subtract from what? 360. The small angles at the points is for 360. And for me to get this one, look at this, up, down. We need to get this angle here, easily. The two angles are equal. And for me to get that, since I know that from here to here is going to be what? 115. I'll get it in an angle. Let's see what theta. Once I get the value of theta, I'll add it to 115. Subtract the total from what? 180 degrees. That will give me the value of alpha. And once I get this value of alpha, that will be the value of alpha here. I'll subtract that from what? 360 degrees. That will be the bearing, which is the angle, the bearing at which was the aircraft is going to fly. So the first thing is to calculate this distance here. Let's see, first calculate that distance. I need to get it in our angle. Now from here to here is 230, and up to this point is 270. So if I subtract 230 from 270, that means this inner part first is what? 40. That's 40. Then here's 115. Then up to this point is 90. Then again, we have this one going like this. That's something like this now. So get this part. That will be equivalent to this. Okay. And here is 90 degrees. The 90 plus this angle is what? The 115. That means I subtract the 90 from what? 115. And that will give me what? 25 degrees. So here is 25. That means this inner angle is what? 65 degrees. So now the distance, I'll make use of the cosine rule. Now I'll get this square equal to 200 square plus 150 square minus 2 times 200 times 150 cos 65 cos 65. So I'll get this square equal to 2 to 500 400 150. That'll be 60,000 here. In cos 65, 0.4226. Well up. This and this one give us 62,500. Multiply 60,000 by 0.4226. So I get 25 25356. Two five three five six 6,500 minus 25356. So I'll give 37144. The square roots, that'll be 192.17. 192.17. Square roots 37144. That 192.17 kilometers. I'll actually approximate that. So I'll get what 190 3. 190 3. So the next thing now, let's get the value of theta now. Using what? The sine rule. Using sine rule. Now let's sine theta all over the side facing theta, that's 150. Sine theta over 150 equal to sine 65 all over D, which is 192.7. So we get sine theta equals 150 sine 65 all over 192.7. So we get sine theta equal to 150 sine 65 that'll be 135.95 all over 192.7. 135.95. So when we divide, get sine theta equal to 0.7077, so 7055. So we get 44.817. 44.817. So theta will be sine inverse of 0.7055. So that theta will be 44.87. 44.87. So that's the value of theta. So now we are looking for alpha. So now we get alpha. Since from here to this point is 180, we'll get alpha will be 180 minus 115 minus 44.87. We'll get 180 minus 115 minus 44.87. That'll be 20.13. 20.13. So the bearing we are looking for now bearing is 360 minus alpha. That's 360 minus 20.113. That'll be 339.9. 339.9 degrees. It's not something difficult. It's not something you cannot solve. Try and look through everything we've done. Go back, look at what we did in part 1 of this series. Okay, so I can take it again from part 1 up to this part 2. If you have not watched for the part 1, to give you a better understanding of what we've done. If you've enjoyed this class or you have learned something from this class, ensure you hit the subscribe button and I'll see you in our next class.